Hello everyone, welcome to the second trigonometry video for the prep for physics. This one is going to be more algebraic instead of geometric like the last one was. So I want you guys to just search up right now on the internet all of the trig identities because you're gonna need to basically memorize them. I'm not gonna go over their derivation because it's not really important, and you can just watch another YouTube video on that if that helps you. But basically just know them, because when you're solving equations, you're gonna need to know all of them. For example, I'm gonna give this really basic one right here. Tangent theta is equal to cosine theta, and we want to know what is theta. So the first identity we want to use here is sine theta over cos theta is equal to cos theta. Next, we can multiply both sides by cos theta, so we can get sine theta is equal to cosine squared theta. Now, how do we solve this? Well, we know, I didn't go over this, but I encourage you to search it up. It's called the Pythagorean identity. It's the easiest one to derive, and it's that this is actually equal to 1 minus sine squared theta, because sine squared theta plus cosine squared theta is equal to 1. Okay. Again, not going to derive it. You can watch your own video on that. I'm just going to be using them. So now we can bring everything sort of over to this side. We'll have sine squared theta plus sine theta. Minus 1 is equal to 0, right? This is just a quadratic. So what multiplies to negative 1 and adds to 1? I can't think. I'm just going to use the quadratic formula. Okay, so we have negative 1 plus or minus the square root of 1 minus 4 times 1 times negative 1 over 2. Right, so then this is just going to become addition, and we'll have negative 1 plus or minus root 5 over 2. And therefore theta is going to be equal to the arc sine of negative 1 plus or minus root 5 over 2. There we go. Now the range for the arcsine, the domain for the arcsine function is limited. So normally I would make sure that this was in the range, because this could be an extraneous answer. However, that is an exercise for you guys if you want. I don't really care at the moment. But you can see how a lot of times you're going to have to use the Pythagorean identity. You're going to get a quadratic, and you're just going to have to use the quadratic formula. And that is that. It's not too bad. Another cool problem is, let's say we had some number a to the power of sine squared theta plus a to the power of cosine squared theta is equal to some number b. So how do we solve this? We're solving for theta, by the way. Well, we do know I'm going to let sine squared theta equal to k. Therefore, cosine squared theta is going to be equal to 1 minus k. So now we have a to the k plus a times a to the minus k is equal to b. So what I'm going to do is multiply everything by a to the k. So we'll have a to the k squared plus a minus b times a to the k is equal to 0. Right, now this is just a quadratic in terms of a to the k. So a to the k is going to be equal to, let's see, it would just be b plus or minus the square root of b squared minus 4ac, which is just 1, over 2. So k is going to be equal to log base a of b plus or minus the square root of b squared minus 4 over 2. And of course, check that this isn't going to produce an imaginary result. For example, b squared minus 4 has to be greater than or equal to 0, which means that b squared has to be greater than or equal to 4. Okay. So, in other words, b is greater than or equal to plus or minus 2. Which just means, this is just another way of sort of saying b is greater than or equal to 2, or b is less than or equal to negative 2. So very simple. Don't forget restrictions. They are important in physics problems, especially because, you know, if it doesn't like make sense physically speaking, like you're gonna get the answer wrong. But yeah, those are basically some basic algebra problems. And if you don't know log yet, I'm gonna go over that next. So if that last part didn't make any sense, don't worry. But anyways, I'll see you guys in the next video.